Hi folks, I welcome you back to Global Education Zone, and in this episode I'm going to be teaching you guys how to draw the plan and the true shape of the section of a frustum of a cone. So first of all, you have to divide the plan into 12 equal parts, and then you project these points to the base of the front elevation. So now I'll project the divisions of the plan. I'll project them onto the base of the front elevation. So that's what I'm doing right now. So with this the combination of the set square and the ruler. So that's how we do it. Let's project these divisions. I'm projecting them to the base of the front elevation. So I'm taking two divisions at once, because some of them coincide vertically. They're on the same vertical plane. Then finally, let's radiate those lines upward to the apex of the cone. So I'm radiating them to the apex of the cone right now. So consider this procedure of radiating them to the apex of the cone. Now I've radiated the lines to the apex of the cone. The next step is these points where they join, we are going to take note of it. Let's project them back to the plan. So project the radiations back to the plan. So where they cut the plan, that's what we used to call the true shape. So this one it was projected here. When we radiate it back, we'll get something like this. Point here. Now we radiate this one backwards to get, so we're going to radiating them back from once they hit the truncation plane, you radiate them back to the points. This will give us the points around. Now we're done with that. So let's number the size of the cone. Let's call this A, B, C, D, E, F, G, H, I, J, K, and L. Now where these points intersect each other, I will be noting them. For example, look at this A. The projection of A comes back to hit A at this point here. So I'll dot it here. Now the projection of B comes back to hit B at, follow this line down, get it here. So I'll dot it here. Now the projection of C, when it goes upwards, it comes back to hit C here. So the projection of D, when it goes backwards. So now we don't know what it goes backwards to hit. So all you need to do is you just draw a horizontal from that point of that D, because D is a vertical. It is on the center line. So when you in the radial method, when you are dealing with center lines, all you need to do is you just take a line from the center to the edge, and then you cut that line. That line will correspond to the distance from its projection. So I'll do that upward and downward because they are on the same vertical plane. This will be my points for points D and J. Okay, so then we have for E. The projection of E hits the truncation plane and comes back to meet E at this point. The projection of F hits the truncation plane here and comes back to hit F here. The projection of G hits the truncation plane, comes back to hit G here. The projection of H hits the truncation plane, comes back to hit H here. Then for I, hits the truncation plane and comes back to hit I here. Then for J, we'll go down for J. Then for K, it hits the truncation plane, comes back to hit K. Yeah. Then finally for L, it hits the truncation plane and comes back to hit L at this point. So you can see we have this series of points that would form the true shape. So all you need to just draw a faint line through all these points. So you are going to use this line, and you are going to use those faint lines to trace the path of the curve. And that curve will show the truncation as seen from above. That is the plan. So the next thing to do is to join these points together. So as you can see, that's what I'm doing here. I'm joining the points together. So to trace the curve of this shape. So as I'm joining them, it's forming the shape of the plan. I'm doing that little by little so that I can be able to copy the exact shape. Next we have the bottom side. So I'll do that for the bottom too. So this is the procedure of how to make use of your French curve. Just use it to trace the path you've already assigned to the curve. So finally we are done, and this is the true shape of the plan. So now this is how it looks like. This is the truncation. So we are going to use the hatching lines to represent the truncation. So all you need to do is just put your set square 45 degree and draw hatching lines. This shows that this is a cut surface. It has been cut through. We have the cut surface here. So now this is the cut surface. Then the next step is for us to draw the true shape of the section. You just go to the truncated point and then draw a line. Draw a series of lines perpendicular to the truncation plane. So through each of those intersections. For example, from the edge you have the first edge. Then we have the first intersection here. Then we have the second one. Then we have the center line. You will still project it with center lines. So to differentiate it, it's actually a center line. Now the fourth, we have the fifth here. Fifth, and then we have the sixth. So finally, let's copy the horizontal distances from the plan. So basically, I'll do that. Let's draw a horizontal plane. So I draw the distance, each of these points. So I advise you do that before you draw your curve, but it's still okay. So for this distance, we have the 0. This is 0. So now I've lost track of those points, but I can still imagine that they'll be here. This should be for the B, and this should be for the C and D. They are on the same line. Then we have the D and E. They are almost on the same line. Then we also have the L and this almost on the same line. This one almost on the same line. So that's approximating it. Yeah. So yeah, so we have the bottom. That's for this, and this. So we have this middle line. We have 1, 2, 3. Middle line 1, 2, 3. So this should be 1, 2, and 3. So this one is non-existent. So it's 1, 2, 3. So now I'll draw a particular line to show the parts. These are middle points 0. Let's call these this is for the B. Let's call it B. B, and this is for B and F. Then this is for C and E. C and E. This is for D. This is for L and H. This is for K and I. And this is for J. So let's transfer each of these the measurements to that true shape. So let's starting from this point. So I'm starting from this point. This will be the bottom of my curve. So I'm opening my compass, copying the curves. But just the way it is from bottom to up. I don't even need to write it again. So 3. 4. 5. Finally 6. So let's draw lines parallel to the truncated plane through these points. So I'll take it from, so this is the bottom, next, second, third, fourth, the fifth, and the sixth. Now I'll be following the lines of the points on the from the horizontal. I'll be following those points. I'll be using those points to get the. So let me angle it this way so you can see it. Now we'll be following the distances. So we have for the A. So this is for A. This is A, and A will intersect this line. Which one? It intersects the this is for 0. This is for A. This is for the midpoint. The midpoint is for A and G. So A and G will intersect the midpoint. That is the 1, 2, 3 for the fourth line. So A will intersect at the 1, 2, 3, 4, the fourth line. and also G will intersect the fourth line. So that's basically how we do it. So this is the midpoint here. That's the midpoint here. D. D will intersect the top. G will intersect the bottom. Then all the rest we just keep pointing them like that. So we have this, we have this, we have this, now we have this. So finally the last thing to do is to just draw a line, a faint line that will tell us how this curve is going to go. So here we go. This is a faint line. So I can now draw the curve. I'll trace the curve out using the French curve. That's quite simple. So I'll start from the sharp curves first, so that I can fit in. So I have the sharp curves. Those are really sharp. I also have this final one. So I can now make use of the normal curves for the rest. So I have this one. So we have this one too. And finally, the last point of the curve, which is here, which is what we will draw. So this is the true shape of the section of the frustum of the cone. This is true shape here. So we can also use hatching lines to show that it is actually a cut surface. So that is optional, but it's advisable. So you are trying to denote that this is the section surface. So finally guys, this is the true shape, this is the front elevation, and this is the complete plan. So thanks for watching.